What comes to your mind when you think about new releases of framework like Spring and Spring Boot? As a developer, I'm usually excited to work with the new features and hope they will address the pain points that I have with my existing applications. For example, if I talk about Spring and Spring Boot, support for building GraalVM native images, which means smaller memory footprint and faster startup times. Observability that works seamlessly in natively compiled applications. Declarative HTTP, where I can annotate the methods for HTTP exchanges. But this is just the tip of the iceberg. So, what are the features that you should be excited about? Also, when you should be using these features and when you should not be using these features? Those are great questions, but I don't have answers to all these questions. Guess what? We are fortunate to have the right expert with us today to answer all these questions for you and more. Josh Long. Hi, everyone. Thanks for joining in for another IntelliJ Idea live stream. I'm your host, Mala Gupta. And here we are with our amazing speaker, Josh Long. Hey, Josh, it's a pleasure to have you present with us today.
Good morning, good afternoon, good evening to everybody. Good to see you, Mala. How are you, my friend?
I'm doing good. Thank you so much. And looking forward to learn more about the features of Spring that you will be talking about today.
Thank you. I appreciate the opportunity.
Thank you so much. The pleasure is all ours, and to everyone who's watching this live stream. If you already are a Spring developer, I guess you probably already know who Josh is. For those who don't know him, he's the first ever Spring developer advocate, a fellow Java champion, Google developer expert for Kotlin, author of 6 books on Java, YouTuber, podcaster, developer. Josh, can I simply say that you're superhuman and not say anything else?
Okay, you're talking about our friend Dr. Subramaniam. That's a superhuman. You and me, the rest of us, we are apostles in his stead, I think. But yeah, no, that's good to see you, my friend. I was on the internet looking for the newest version of one of your certification books just so I could learn about the latest versions of Java because it's changing so fast, and even as a Java champion, I find it very hard to keep above water. There's so much new amazing stuff.
That's true. We have two new releases of Java every year now. So it's hard to catch up. So I know. And
the worst part is one of them comes in the middle of the year, and people are vacationing, and I'm like, I want to play with Java. Leave me alone. But oh well.
Right.
It's a good problem to have,
Josh, Yes, that's right. I have a quick question for you before I let you move forward with your presentation.
Okay.
You mentioned
Sure.
that Spring 6 and Spring Boot 3 mention about new baselines, and you talk about Java 17 and Jakarta EE 9 as being the new baseline. What does that mean for developers?
It means the obvious, which is that there are new versions of software, and if they want to take advantage of the new versions of software, they need to move forward, And just like with testing, you take away the risk of moving to these versions by moving often, right? If you're scared of moving to a new version, then do it all the time. So that way there's less of a delta between one version and another, and that way there's less risk. It's as my late father used to say, it's a cinch by the inch, hard by the yard. Which, if you don't speak American, that means it's easy by the centimeter, hard by the meter. Like don't wait until it becomes this big, massive jump you have to make. Just do it piecemeal, slowly, quickly, all the time.
That's so much true, because if you wait long, the inertia sets in and so much of changes, and that you are really scared to make the change. That's perfect. And I will not hold you long. I just want to share quick housekeeping details before I let you take the center stage. And everyone who's watching, please use the YouTube chat to post your questions. Josh will answer the question towards the end of the session, but I'll try my best to answer the questions as much. And a lot of people who are watching, they answer the questions as well. And the session is being recorded and will be hosted on IntelliJ Idea's YouTube channel and also on JetBrains Twitch channel. So if you haven't already subscribed to the channel, now is the time to do so. And if you like today's session, which I am very sure that you will, don't miss to like the video. So Josh, the stage is yours.
Hey, thank you so much. I appreciate that. Let's see, where are we here? My name is Josh Long. I work on the Spring team. I trust you can still see my screen. Is that true? Yeah. Okay, there you go. Good. My name is Josh. I work on the Spring team. It's so very lovely to see you all today. Well, to be here with you all today. Thank you so much, Mala, my friend, for giving me the opportunity. I work on the Spring team as a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion. I'm also a YouTuber, not nearly so prolific or useful or capable as Mala and the rest of the team over at JetBrains. But if you want to settle, if you've seen the best and you want to settle for the rest, come to my YouTube channel at Coffee Software. The code that we're going to look at here today, my friends, is Josh Long, github.com, Josh Long, Bootiful -spring -boot -3. And there's a bunch of other coordinates because, friends, if I am nothing else, I'm at your service. I'm here for you. So let me know what I can do. Talk to me. Find me on the Twitters. Or if you don't, if the bird site is already burned down by the time you're watching this, go check out Mastodon or LinkedIn or email. I'm one of those people that still does email. Not often, not eagerly, but it does get done most of the time. I also have a podcast every Friday for most of the world, but for the West Coast of the Americas, it's on Thursday, and that's it's every week. And I even had Mala on the show, right? That's the caliber of the guests I've managed to trick into coming onto the show. And let's get started. I think we've got that set up. Let's move on. So today, my friends, we're going to talk about the latest and greatest in Spring Boot. And of course, as Mala just hinted, there are some new baselines and some new requirements for this. First of all, you need to use Java 17. So when we go here to start.spring.io to build a new application, we have some choices down here. First of all, what name would we like to give our application? I'm just going to call it service. I'm great with names. I mean, you can see I just called this service. I called it service. I get that from my late father. My late father, we had a little white dog that came to our house, and we just adopted him. And my dad, again, great with names, just named it White Dog. And then we had another white dog 10 years later after that first one died. And my father decided to name it Two, as in the number, or TOO. I don't know. Either way, it was hilarious. And so I've taken that tradition. I'm just going to call my service, right? And so we're going to build a new application. We're going to use the newest version of Spring Boot that was just released yesterday, 3.03. H2, we're going to bring in an embedded database. We're going to bring in JDBC. We're going to bring in the Spring Boot actuator to support observability. We're going to bring in the web framework, and we're going to bring in the GraalVM-native image support, okay? Now, by default, you're going to be choosing Gradle. Unless you specify otherwise, you'll get a Groovy and Gradle version of the build. Personally, I kind of wish it was the Kotlin version of Gradle, if it has to be Gradle. But whatever, you can choose that too. That's over here. And then, my friends, like I said, you have the choice of what version you want. And friends, these radio boxes are alive, for you see, they imply a choice where there is no choice. Java's 19 and 17 are the only real, practical, applicable, useful, viable choices here. Java's 11 and 8 are long since deprecated, creakingly old, no longer required or supported or available or useful in any context whatsoever. You see, Java 17 is the current long-term supported version of Java. It is faster, more secure, more performant, more robust, more capable than Java 8, for example, and Java 11. It is technically superior in every way. It's also morally superior in every way. You won't like the look of sadness and despair in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17 or later. I'm going to use Java 17 because that is a current long-term supported place to park your code. But remember, Java 20 is just around the corner. We're talking weeks, not months at this point, right? Well, maybe months, but not even that much, right? Very, very soon we'll have Java 20. So this will get, superseded very, very quickly, by which point Java 17 will be a year and a half in the rearview mirror. And that gets us to another point, which is Java 17 may seem aggressive today in early 2023, but consider that we just released this version of Spring Boot on Thanksgiving Day in November 24th, 2022, just last year, by which point it had already been more than 5 years since we had released Spring Framework 5, the last major generation of Spring, which was the foundation for the last major generation of Spring Boot 2.x. That 5-year time is a huge half-decade period, right, in which a lot has changed. And let's extrapolate forward. We can't see the future. Nobody can. But suppose that 5 years hence, we're still writing code against Spring Boot 3.x, and this is still the current major generation, at which point you'll still be able to use Java 17. But erstwhile, people will be able to write code against what? I mean, imagine, extrapolate 10 years forward, right? What does that mean? We got, 5 years forward, 10 major versions. Hence, if we're at Java 29 by then, maybe even Java 30, depending on the timelines, people could be writing code against Java 30, and there you are still writing code against Java 17. You're going to look very silly at the party. Don't do that. Do the right thing. Move forward as often as you can. So I'm going to hit generate, and we're going to open this up in our IDE. I'm going to open up my service, and again, I'm going to use IntelliJ. You can use anything you want, but why would you use anything else, right? This is just a nice piece of kit. It just works. It's fast. I'm downloading some of these dependencies. They just got released last night, and I just haven't had the minute. There you go. Fine, it's up and running. Okay, up and running. So public static void main, entry point into our application. We're going to build an application that just talks to a database. So I'm going to describe the data in our database using a record, right? I love records. These are one of the nicer features of the modern Java, right? So we can just say, oh, so good. I love it. Look at that. Look at that beautiful record. So I'm going to use that record to talk to my database. I'll create a customer service, and this service is just going to be a regular old JDBC template powered thing. Now, the JDBC template is a thing that's been in Spring for decades. It's not new. I'm sure you've seen it before, but it's just a great way to build simple data access logic. And we're going to build two endpoints here. Two methods even, right? One that gives me all the customer data, like so, right? So this.template.query, select all from customers, right? And we're gonna need a row mapper to do that mapping from a result set to a customer object. So I'll create this. And it's just a simple callback. It just happens to work really nicely as a Lambda. So you can use that. Oh, what have I done here? I've made quite the mess. Okay. rs.getInt. Okay, rs.getString. Good. There we are. So there's that. And of course, this boils down nicely into a Lambda. Look at that reduction in code and verbosity. And I'll just pass that in here, this dot customer row mapper. Voila. Okay, there's our customer row mapper for all the records. And I want to get just some of them by ID. So I'll say customer by ID. Okay, integer ID. And here I'll say this.template.query for object, select from customers where ID equals this, passing in the row mapper and the ID, okay? Is that the other way around? Yeah, that looks right. Okay, good. So I've got now my two objects. I've got my two different methods there to get data from the database. I need to have data. I need to have a database too. So what I'm going to do is I'm going to go to my source main resources folder. I'll create a schema.sql, and there I'll create a table, ID, serial, primary key, name, var, car, 255, not null. Okay, and you know what I think I might have forgotten to do, my friends? I may have forgotten to, no, I did. I got the H2 database. Good, we're good. So that's going to create an embedded in-memory SQL database. And then I'm going to have some data. So I'll create a file here called data, insert into customers, name, and we'll just put some people, some awesome people. So Mala, of course, we'll put there. Why not? I can be a customer. Put some people in the Spring team. There we go. We've got Madura. We've got Olga. We've got Yushin. We've got Violetta, etc., etc. That's 8. We need Stefan. Why not? Okay. Oops. Two. Just one, Josh. Just one. Okay. There you go. Good. So there's 8 records. Now, if we start this application up, I want to see it in action. So what I'm going to do is I'm going to create a bean that listens for an event, the application ready event, and I'm going to respond to that event by just calling into my service, right? So when this event happens, I'm going to inject that customer service that we just created there, CS, okay, and we'll say cs.all.for each system out print line, okay, not a big deal. There's this. Let's just run that and see what we get and see if that's working so far. Looks like I've failed somewhere, okay? I've done something stupid. Table customers is not found. And yet, I feel like, customers, insert, rats. Okay, customers, find and replace. Do that quickly, thank you. Fixed it, let's rerun. All right, looks like it's working. Great, let's build a HTTP endpoint, okay? At controller at response body, and I'm hesitating to call this a REST endpoint. It's just an HTTP REST-ish endpoint. It's not really REST, but it works. So we're going to inject this service into the constructor, and I'll create an endpoint here called customers, by which I'll return all the customers, right? Delegating to my service, as you can imagine. All, look at that. The IDE basically writes the code for you. All you got to do is get out of its way, which is great because I more often than not seem to get in the way, and it's a little dispiriting, but I do try. I do try to do right by my IDE. I feel like it's carrying most of the load though. There we are. So we're going to restart this. Okay, localhost customers 1. There we go. Okay, 2, good. Now I also want an endpoint to get me the data by name. Okay, so I'll say by name, string name. And actually, if you think about it, this is going to conflict here. So really, if I had one endpoint, I don't want the ID, I want by the name. Okay, so let's just refactor this a little bit. I'll say rename by name, and this will become a string. And I'll say this is going to be where name equals this. Okay, and we're going to pass in that variable, which I'll now rename to be name. Very good. That should work. Okay, so if we go here, we say Josh, customers Josh. What did I do wrong? Say, okay, require ID. All right, where's my controller here? Name. Oh yeah, I have to synchronize these things. If you want to avoid the synchronization issues, you can just name that like that, and then it doesn't matter what you name the variable, but you have to have some way to match these things, obviously. Okay, very good. So that works. Now the problem is I've got a capital letter J. What if I do a lowercase j, right? In the browser, which keeps the request, it works still, but obviously that's not going to work there. And when I get that error, you notice that I've got this like JSON HTTP error. It's not standard though. This is not a consistent thing. This is just what Spring Boot does by default. So one thing I would want to do to make this world a little bit better is to use a consistent error. And to that effect, to that end, we have the ProblemDetails RFC. And this is a RFC that's got new support in Spring Framework 6. It's a standard way to propagate errors, and pretty simple. You just go to your properties and you say problem details enabled equals true for Spring MVC or for Spring Webflow. They're two different things. And then what I want to do is I'm going to get an exception. You can see I've got an exception. This is an empty result data access exception, but that's not really this. That's a symptom of the problem. It's not the problem. What I'm going to do is I'm going to insert some validation here. I'll say name.charAt0 is uppercase, right? Character is uppercase. So the name must start with a capital letter, right? Okay, so let's restart that and let's see what that gets us. And if we go to the command line here, again, we run that, we got the error, but now the error that we get on the console, and we see the exception is an illegal state exception, which we can deal with. So I want to centralize my error handling first, okay? Before we can use the problem details. It'd be a shame to duplicate, to have error handling logic strewn about all my different controllers when I could centralize it. So I'm going to create error handling controller advice. And if you know Spring, then you know this component type is a way to centralize error handling. So I'm going to say for an illegal argument, an illegal state exception, public void handle illegal state exception. And actually, if you think about it, this is a little bit redundant. And so Spring doesn't require that you specify it both times. I can just inject the exception there. And what I want to do is I want to return a response that contains a problem details, so that I can understand what's happening. So problem detail, and I'll say var pd equals new problem detail, problem detail dot, right? Problem detail dot for status, HTTP status code. What do I want to do? Maybe 404, right? That seems reasonable. And I want to specify a message as well. I can do that. I can say pd.set detail and then provide a string. Then name must start with a capital letter. And you can imagine easily creating some domain specific business logic here that has a custom exception. That seems even more useful and so on. So there you go. So I've got now this problem detail is going to create an HTTP status. The controller will now respond with that exception. If this is thrown from any controller, it'll eventually bubble up and land here, and then I can control what gets responded, what gets sent back to the client accordingly. Okay, so there's my new problem details endpoint. And you can see it's a little different from the other one. It's just consistent. That's nice. So now no matter what the language or technology you're using, good. Now, of course, I'm making this request. It's not particularly expensive, but one thing I want to do when I build a service that's intended for production is to support observability. And to that extent, to that end, I have my build.gradle file. I've added the springboot actuator, which is your one-stop shop for sort of observability use cases. It surfaces different endpoints like, let's see, exposure to include health, problem details, probes enabled for Kubernetes, show details for health, etc. Let's go ahead and restart that and see what that has bought us. Here we are. Localhost actuator metrics. It gives us metrics. And this metrics project is powered by Micrometer. Micrometer is a vendor-neutral application observability facade. It provides like an SLF but for observability use cases. So you get dimensional metrics and you get distributed tracing, right? So popular observability systems, and you can see there's a number of different integrations here. And this website needs to be updated because that's really the old way, right? We talked about Micrometer before in the past, and the situation was we have Micrometer at the very bottom, and then Spring Framework depends upon Micrometer, and then Spring Boot depends on Spring Framework, and then Spring Cloud depends on Spring Boot, and then on top of that, for distributed tracing, we had Spring Cloud Sleuth. This is the old way, and you can see the problem here. Micrometer sits below everything, whereas this sits on top. And so that means that Spring Boot and Spring Framework and Spring Cloud couldn't depend on Spring Cloud Sleuth because that would create a circular dependency. So it meant that Spring Framework was not instrumented to support distributed tracing. Likewise, Spring Boot and so on. So now we have gotten rid of this project and we've integrated both metrics and tracing in Micrometer. And that's a new thing you'll see in Spring Boot 3, along with a brand new unified abstraction called an observation. So let's rewrite this code to support that new observation. There's two ways to take advantage of that. One is just to use ye old annotation, I observed. That's fine. But I like the more explicit style. So I can say observation dot create not started. And I'm going to say, okay, by name. Okay, fine. In order to make this work, I need to inject an observation registry. Okay, so observation registry like so. Inject that into the constructor like so. And obviously put that up there. And now I'm going to just say this dot observation registry, and then I'm going to say dot observe. And I can pass in a supplier, and I can just do as I was going to do, right? I was going to send this data back like so. There we are. Very good. And replace it with Lambda. Very good. Okay, so there's my new encompassed, sort of enveloped call. I'm making a call. I'm creating a metric called by name, which is every single time this pathway is invoked, I'll get this new metric increment. And then I'm also creating a scope in which, had I used something that was instrumented for distributed tracing, like the reactive web client or the REST template or something like that, I would automatically start a scope, start a span, right? And this is part of a larger trace. You can have multiple hops in the journey from one system to another, right? You might go from one node to a message broker to another service to another service. All of those different hops are part of this larger trace. Each hop is called a span, and this automatically either joins up with an existing trace if it's already being propagated in the headers automatically by the framework, or it'll create a new one for you if this is the sort of genesis of that trace. And that all happens with a single abstraction. So now let's go ahead and restart. Go here, localhost actuator / metrics. Let's go to our localhost customers endpoint, and we'll say, Josh, I'll refresh this a number of different times, okay? And if I go here, you can see it says by name.active and by name. I can then go to / actuator / metrics / by name. And you can see I made 13 different calls, and the total time was this, and the max time was that. And if there had been any errors, I would have been able to break that down by the type of errors and so on there. And all this gets reported accordingly if you configure a different binding, if it'll get configured and represented correctly in these different time series databases as well. So this new Micrometer API is hot sauce. It's great stuff. It makes it easier to build more robust, more observable systems. And that is, after all, very important. You can't succeed if you haven't measured the baseline and if you don't know what errors look like. You can't say I won if you don't know what losing looks like. So this is a great way to do that. Now, my friends, we've got error handling, we've got observability. I think it's time to consider our move to production. And here, friends, we have a couple of concerns. Obviously, we need to build a Docker image, and I could spend a whole hour just talking about build packs. This is not a very new thing, though, so I'm not going to spend too long. But suffice it to say, it's a cloud-native computing foundation specification, and it provides a way to take a code artifact, be it a Java jar or .war, or a Ruby on Rails app or Python app or a Node.js application or a Perl or whatever, or even a I refuse to say it. It's not a language. It can't be done. Anyway, you can use that too if you really wanted to and you're sick in the head. This build packs is a great way to consistently build an application container and get it destroyed, get it deployed to production. And that's great. It's reusing a recipe that's been built by the community writ large, right? It's a large scale effort, as opposed to that homegrown Docker file that you and 5 other people over like the last 5 years have been occasionally updating to keep up to date with slightly growing demands, completely ignoring the state of the art in the world, right? Which is now full of bugs and vulnerabilities and all that stuff. Instead of using that, use this build packs. And you can use the pack CLI, but Spring Boot provides a built-in support. So I can go here, I can say, not Maven, I can say Gradle and Gradle W tasks. And by the way, if you see me being a little aloof with Gradle, that's because this year I'm trying to learn, as part of my resolutions, I've got 2 goals. One is to learn Gradle, and the other one is to lose some weight. And I'm definitely making progress on learning Gradle. So you can say build boot image, and all that does is it creates an OCI image of the application using build packs. So you don't even need to download the pack CLI or anything special. Just have a Docker daemon running somewhere, and that'll do the work for you. There's an equivalent thing in Maven. I don't have Maven, but if I did, it's a what is it? Spring Boot build image, or I think it's that. I think that's what it is, but I could be wrong. It's been a few weeks since I've done this. Okay, so that's fine. I'm not going to really show you all that because it takes time and we don't have much of that. The next thing I care about is making my application as efficient and robust as possible. Now, I want to just take a moment here, my friends. Just take a moment to reflect upon the fact that Java is already as efficient and fast as many languages would love to be, and that was borne out by this amazing report from 2018. So 5 years ago, almost. May 20th, almost 5 years ago. This report reflects on the normalized global results for energy, time, and memory. And you can see here, friends, that when it comes to efficiency in terms of like carbon, for energy use, C is obviously the gold standard, the standard bearer. C is 1.0 on this index. Rust is 1.03, C++ 1.34. So ADA, which, I don't know anybody who's using ADA anymore, but just in case, 1.7. And there's Java. So effectively, of the 4 languages which are in actual circulation today, Java's number 4. If you can exclude ADA, which I'm very happy to do, it's still 1.98. So that means it's 2 times as inefficient as C. But keep that in mind, right? Java's doing quite good. It's in great company up here, and compare that to other very popular languages of the day, like JavaScript, which is almost considerably worse, and then Python, which is oh my goodness, way worse, right? So these numbers might have changed ever so slightly, but just keep in mind, Java is actually very memory efficient. It's a very economic, carbon friendly thing to run in your data center already, and it's also very fast. And there are a couple reasons why it's so fast. One is we have an automatic garbage collector that is the storied stuff of legends. It does amazing things for us. That said, though, I think there is somebody else who's got a better claim to garbage collector, right? This is Jesselyn, and she is from the island of Java, Indonesia, which is an island in the country of Indonesia. And she says, the original Java garbage collector. And I believe her. So let's just say that Java's garbage collector is the second best garbage collector after her. So that's part one. Is the garbage collector makes it so you can write code that does inefficient things and actually get really efficient behaviors despite that a lot of the times. Not always. It's not a miracle worker, but it does amazing things. The other thing that we have that makes Java so phenomenal is the just-in-time compiler, which takes your code and where it can be absolutely certain that it has excluded any variances in the type system, it'll convert that piece of code into a native image, just a native image, just an operating system and architecture-specific piece of code. So it'll take frequently accessed code paths, such as you would see in an application in production, and turn it into native operating system and architecture-specific code. That is a phenomenal aspect of the Java language, and it's why sometimes Java applications can, along with the garbage collector, perform as efficiently or more as a mediocre sort of C application, right? It can be amazingly productive and resilient. And large organizations take advantage of this just-in-time compilation For example, Google and Alibaba have talked about how they have a mechanism where they deploy a Java service, they throw some simulated traffic at it to warm up these code paths, and then they turn on production traffic once these applications are warmed up, right? So they can take advantage of the just-in-time compilation. So the question, friends, is if the just-in-time compilation is so useful, if having native code is so useful, why not do it for the whole application? Why not do it for everything? And the reason is because, like I said, you have to be very specific about what you try to compile, right? GraalVM will actually let you do this. GraalVM is a separate research project that came from Oracle Labs, whose lifetime, we just learned at Java 1 last year in October, I think it was, will now be aligned with OpenJDK and with Project Loom, an effort to provide optimizations for Java applications. Hopefully some of that technology will sort of converge with OpenJDK. In short, I see both Project Loom and GraalVM and OpenJDK, I see all these efforts sort of converging, but I can't be sure. No, we're not 100% sure, but it looks likely. They even alluded to that possibility in one of the documents describing Layden's various attempts at condensers and all that. So perhaps, we don't know. But either way, the future looks bright. And in the meantime, we can rely on GraalVM being updated at the same time as OpenJDK. So you can see OpenJDK X and you'll see GraalVM X, very, very, very quickly in short succession right after that. So the GraalVM project has many, many features, and we don't have enough time. We don't have, even if this was a workshop with 8 hours, there's just no way we could cover all the incredible possibilities implied by GraalVM. But one of the things that has become very, very, frequently understood and talked about in the GraalVM project is the support for GraalVM native images through the native image compiler. And it attempts to provide native images for your code, assuming that code can meet the aforementioned restrictions. That is to say, you have to be able to guarantee that certain variances in the type system don't occur. So what GraalVM does is it looks at your code at compile time, and it decides through static analysis at compile time which types you are using. So if your code in public static void main uses another type, and that uses another type, and that uses another type, then it keeps all those types. Everything else that's on the class path that isn't in that bucket of types that it has just discovered, it throws away. Everything else, be it in the JDK, be it on the class path, be it in your code itself. If you have a class just sitting there unused, never instantiated, it'll throw it away. And that's good because it means that the resulting set of classes that gets compiled is substantially smaller and therefore makes for a much faster application. But it can't see everything. Remember, it's doing static analysis, and the Java is amazing. One of the reasons it's so amazing is because it's got this dynamic runtime. This dynamic runtime means that Java, for all of its stodginess and the sort of syntax warts and whatever that have built up over nearly 3 decades of evolution, all of that is still on top of a very dynamic language that has a lot more in common with the likes of Lisp and Ruby and Python and JavaScript and whatever than it does the languages of yore, languages like C and C++ and so on. It's actually a very dynamic language. It has a runtime. You can, if you wanted to, take a Java lang string containing source code, compile the source code, write a class file to the disk, load the class file into the class loader, reflectively create an instance of that class file, reflectively invoke a method on it. If that class, the source code implemented, it says implement serializable, you could serialize the resulting class over a socket and send the bytes to another computer where it could then instantiate an instance of it if you wanted, and then reflect upon it as well. You can do crazy things with Java, right? All at runtime, all after the application has been started and is running and actually serving traffic. What this means is that no static analysis could ever hope to deterministically understand all the potential things that might go, different, might be different at runtime. And so we need to account for those use cases in GraalVM with some configuration. And remember, this kind of dynamic stuff, class loading, reflection, JNI, serialization, proxies, it happens all the time. Every Java application ever written probably has, to some extent, some of this stuff, right? Even if it's as simple as like class.getInputStream. I mean, you're already doing something that GraalVM does not like, and you need to account for with configuration. So you need to account for it, and there's a lot to do. Spring is in a well-positioned place to do that work for you, at least insofar as it concerns code written by the Spring Framework and that the Spring Framework uses. And so in Spring Boot 3 and in Spring Framework 6, the foundation on which Spring Boot 3 is built, we have shipped a new engine, and we're calling this the AOT engine. ahead of time compilation engine. And what that does is when you compile your code, it looks at your code. It actually creates a skeletal bean factory containing all the different beans, all the different objects in your code base. It doesn't invoke them. It doesn't start them up. It doesn't call the constructors, but it does analyze, as it would normally do at runtime. It does analyze all the classes and all the constructors and all the fields, all the annotations, and it gives these callbacks, these post processors, which you can provide, of which you can provide your own instance if you wanted. It gives all these different components, these AOT lifetime components, a chance to analyze all those bean definitions. And then you can automatically emit whatever code you want to be fed into the GraalVM native image compiler as configuration. So either it works just fine out of the box with what Spring does by default, and that's our goal, is for it to just work fine by default. Or if you need to, you can just implement one of these AOT post-processor implementations, okay? Now, again, for the 80% case, we're confident that it'll do just fine. Heck, for 90%, but there might be some use cases where Spring can't understand or see what you're doing. For example, if you, in the constructor of a method, create a class using reflection, and then you decide to reflect upon that class using Jackson for JSON serialization, and you're doing all of that inside this method. You create the Jackson object mapper inside the constructor, you do the reflection on the object that you just created reflection inside the constructor. Well, how is Spring supposed to know that? It doesn't know that you're doing all that. So you need to write configuration that tells the GraalVM image about that, and you can use our AOT engine to do it. But hopefully you don't need to do it, right? If you're not doing anything, shall we say, cute like that, then it should just be fine. So let's just go ahead and do that. Let's go ahead and create an image, and I'm going to call it native compile, GraalVM native compile. Now this is going to take a minute, my friends. This actually takes a fair bit of time because remember, it's analyzing the entire class path. And so now I finally understand this XKCD cartoon, this famous, wonderful XKCD cartoon. For the number one programmer excuse for legitimately slacking off is my code's compiling. And then out the door, somebody yells, "Hey, get back to work." And then the two swashbuckling engineers say, "No, I'm compiling." And then it's like, "Oh, okay, carry on." That's where we are right now, my friends. It takes a good minute on my fairly fast machine to compile this code, right? Yeah, like it's just, I understand that situation, and it's long enough. Actually, here's the problem: the compilation takes about a minute, which is long enough to be annoying because it jumps you out of your flow. It takes you out of the zone. You can't really get back in the rhythm as easily, but it's not long enough to do anything useful. I can't go make a cup of coffee. I can just barely run to the bathroom. I can't really have a conversation or even catch up on email. So it's just the worst. And so the situation is such that now when I do these native image compilations, I start to hear elevator music right in my head. I'm just sitting there, waiting and waiting and waiting. And I hear elevator music in my head while I do these sometimes long running compilations. So I actually asked the Oracle GraalVM project, the official one, I said, "Would you please play elevator music during the native image compilation process?" And I said, "I already hear elevator music in my head while I do these sometimes long running compilations. I just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work." And I do, by the way, very important to stress that. And one of our friends from Red Hat responded with this elevator music, and this is a link to a YouTube video. Somebody else said, and this elevator music, by the way, comes from the GoldenEye video game, the game based on the movie from the 90s with James Bond. It's very funny. Somebody else said, "Hey, I would add that using beeps in general, not only for native image, really helped me reduce the development time," right? And then our friend Fabio Niephaus, who's a researcher on the GraalVM team at Oracle, a doctorate's graduate, PhD graduate, and based in Germany. He says, "Thank you for your feedback." This is such a considered, kind response, by the way. "Thank you for your feature request, Josh. The problem with playing music during the compilation is that it's just fixing the symptoms, and we've been and still are working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption." And then he continues, "Anyway, I have prototyped a -- Josh Long mode, but for some reason I have the feeling my PR will be rejected, probably because of the copyrighted music." So here's his prototype, and what it would have done is you say -- Josh Long mode, and it would print music brought to you by Josh Long, and then it would have some ASCII art that rendered my ugly mug. So I think that would have been a boon to the evolution of the technology. he says, he continues, but for some reason I have a feeling the PR will be rejected. So that's a bit of a bummer. It's a bit of a bummer. But he says, on a more serious note, yes, we could probably add a ring bell when done option that prints the bell code after the compilation process. So that's progress. It's not what we came here for, but it's progress, right? And I'd like to believe that one day maybe it'll get installed. In the meantime, there might be a bell code. I don't have it yet though. So let's go check on our bell and see if it's done. There we go. About 1 minute and 7 seconds. It finished. We go to the target directory. Sorry, the build directory, because I'm using Gradle. Native compile. There we are. There's my service. Let's go ahead and start that up. Okay, so let me start that up again. There you go. So about 0.87 seconds processed in total, was running for just under a 1/10 of a second. Okay, so what that is I've actually created an application that starts up as fast as a light bulb. First of all, yay. But much more importantly here, because I don't care about startup time. Unless you're doing serverless, why do you care? Nobody cares. But what I care about is memory footprint. And here, GraalVM is amazingly useful. Watch this. So I've got this GraalVM Java process that I created. That's my Spring Boot application. It's got a process identifier. Where does it say? Process identifier 4575. I'm going to go here now, and I'm going to do PSO RSS, that one. And that's going to say, that's in bytes, I think. So it's showing me that I've got about 100 megs of RAM I'm using for this Java process. So that's an embedded SQL database and an embedded web server, all the frameworks that you're using in Spring Boot and all that stuff. 100 megs of RAM. Now, I don't know how much your application on the JVM is taking today. I'll bet it's, let me just guess, wild guess, about a gig. Is it about a gig? Probably, right? Most JVM applications are. And a large part of that, by the way, is just because of the JRE. The JRE, in order to maintain that incredibly dynamic runtime, has to keep a lot of things about just so that your application can be more dynamic, just in case you decide to do something. So 100 megs is a win. That's a 1/10. That's 10% of your current production footprint. And I'll bet a lot of you are using even more than that, right? So imagine 2 gigs. Now you're talking about 1/20th, right, of your production footprint. That's a big deal. You could deploy 10 of these applications, distribution, right, get more scale, more availability, and do so at the footprint cost of just one JRE application. That's free win, right? Or you could just keep things at the current levels and then just reduce your data center resource spend by 1/10, right? By 90%, right? You keep a 1/10. That's a big deal, friends. It's a big deal because it's a small amount of RAM. So I love GraalVM. I love it, I love it, I love it. Let me just start that again. I forgot to mention that, of course, you can do all the usual things. There's my customer data. Everything is working, right, as you would expect. Good. Now, let's build a client to talk to our GraalVM native image service. And by the way, if you want to learn more about this, Spring tips, GraalVM AOT, Josh Long, not this one, this one. Watch this video I did. I put it out a couple of months ago. It's got 2 hours of content. It's a deep dive, a super deep dive in all things GraalVM and AOT. So you're going to want to watch this. It looks at everything, basically. So it starts from the absolute basics, which is what we just did, and works all the way to the point where you're doing the same things as we are as framework developers. So you understand how to build out and support code as a framework in your organization. So if you want to learn every little nuance, watch this video, and you'll be basically at the same place as I was, as somebody who's worked on this code and been a contributor to it for years now, up to 3 months ago. Okay. Now, let's build another service here, and we're going to call this one, we're going to go to start.spring.io, and again, I'm going to be very good with the names. I'm just going to call this client, okay? And here, I'm going to use the reactive web support. I'll use the GraphQL support. I'll use Spring Cloud Gateway, and I think I'm happy with that. Maybe I want GraalVM as well. Of course I do. I want GraalVM image support. So I'll hit generate and open that up in my IDE. And again, it doesn't really matter what you're using so long as it supports this. But of course, what does that mean today? It means IntelliJ, right? Downloading all the dependencies. I don't want the plugin. And this is the only bug I've ever seen in JetBrains, which is, it's not even a bug. It's just funny. Why would they voluntarily tell me every time it starts up that GraalVM debugging doesn't work on Mac and Windows, which is like, at least 2/3 of the community? Just don't mention it. I wouldn't have even noticed. You could just disable that. I think that'd be fine. Okay, so it's very honest, it's very forthright, which I appreciate in my IDEs, but nonetheless, unneeded. Or at the very least, just tell me once, and then we'll agree to disagree and we'll move on. You can stop showing it to me. Anyway, here's my public static void main. I want to talk to that service that we just built. We did all that work. I want to build a client that talks to that service. And of course I could, I could build a, let's see, I'm going to build a class customer client. And in order to do my work, I do need a pointer to the customer that we just created. So let's find that customer here. Okay, there's our record. I'm going to do something terrible, something that you should never ever do ever, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste. Okay, there's that. And I'm going to build a client. I could just build a client manually. I could say, all, and I could use the reactive web client that I can construct here to do that work. But the problem is that this is just work. And this code is, it's burdensome and it looks suspiciously like work. And I'm not a big fan of work. So instead, what I'd like to do is to have some sort of auto-generated client. And I can do this. There's already been a number of different ways to do this in the Spring ecosystem. There was Spring Cloud Square Retrofit, which does reactive HTTP clients based on interfaces. There was Spring Cloud Open Feign, which does this for non-reactive declarative interfaces. And of course, the project that I started was Spring RetroSocket, which is a declarative interface-based mechanism for creating clients for reactive RSocket-based services, not HTTP. All those have been subsumed, however, by the new inbuilt support in Spring Framework 6 for declarative clients. And so today, I just say customer client, and I'm going to create some endpoints here. So I'll say customer all, and I'll say by name, and I'm going to use a client-side equivalent to get mapping, right? Get mapping is what we use on the server side. On the client side, I use get exchange. So customer's name, right? And I can use this client side and server side variable called path variable. Over here, I'll say get exchange customers. And there you go. There's my definition. Now I need to actually factory an instance of this bean. So I can create a bean here. I'll say web client. I need to create a customer client like so. And I'm going to inject a web client builder because I need a pointer to a reactive non-blocking web client. And I want my web client to be specific to this customer client and to have a base URL that's appropriate for this client. So I'll say HTTP service proxy factory dot builder web client adapter dot for client builder dot base URL HTTP localhost 8080 okay dot build and that's going to be the client. And then I want to actually build an instance of my interface with that that client. And I could actually, I could stash this as a separate bean, but in this case, since I'm only doing one, it's fine to just do it inline. So basically, I'm creating a client for this interface. I'm telling it to use a web client, a reactive non-blocking HTTP client called a web client, and I'm telling it to prefix all URLs with HTTP localhost 8080 /customers /customer's name, etc. So it's taking that as the base. All right. So now I've got this client. I can actually just use it when the application starts up. So application listener. Application ready event. Okay, return event. And we'll say customer client cc.all.subscribe. Look familiar? It should. This is the reactive sort of equivalent of what we did in the service. Okay, let's just go ahead and restart that. Oh, it's going to fail because we're on the same port, isn't it? So port 9999. Okay, let's restart that. Come on. Take two. Okay, there we are. It's worked. There's our data on the client side, right? We're making a network call to the other service when the application starts up. That's one way we can easily integrate our clients with our services. Another might be to use Spring Cloud Gateway. So here, Spring Cloud Gateway is like a proxy. It's a micro proxy. And you describe routes. And these routes match incoming requests that are bound to port 9999. And then they match the route. So you say r dot, let's see here, routes dot, route rs, and this goes back here. I can say rs, when the request comes in, I match the request on / proxy, and I'm going to send the incoming request on port 9999, blah, 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 proxy. I'm going to send that over to localhost 8080 customers. The problem is this is a path, and the incoming request by definition already has this path. So I need to change that path, and I can do that using filters. So I'm going to say set path equals customers. And so I'm using these filters to act on the incoming request and to enhance it, transform it, modify it, whatever, in any way that I need to. Here, I'm just changing the path. But there's all sorts of other filters, like, hey, I want to do a retry, or I want to do an add response header, right? HTTP headers, dot access control allow origin to support cores, or maybe I want to do rate limiting, right? You can do all sorts of things there to make your application more resilient. And you can put this in front of your downstream microservices. You can impose authentication. You can impose certain headers, et cetera, et cetera, et cetera. So let's go ahead and restart this. Faster. Okay. Localhost 9999/proxy. There's the data from the downstream service. In fact, if I do -v, you can see that when I made the call on the command line, I get access control allow origin asterisk, right? That's the extra header that I added. So now my client is calling my service, and they're getting the data from the downstream service, and they don't know that there's actually a little bit of indirection there. It's fast as can be, and we've added core support there. So now my JavaScript client can talk to that endpoint and make requests with abandon, and I don't have to change my downstream microservices. Spring Cloud Gateway is amazing. That's another great, easy way to connect my services. And finally, another way still is using GraphQL. Now, GraphQL has a very simple idea. The core conceit is, hey, I have a bunch of microservices. They all stand by themselves, but my client, my Android device, my iPhone device, whatever, it doesn't want and need and shouldn't have to make 10 different network calls to 10 different microservices, duplicating authentication logic, duplicating the payloads and the requests, and creating 10 threads. Imagine you're on an Android device roaming through the in the middle of the desert somewhere, and you've got 3% power, and you need to like open this app, and it makes 10 different network calls, spins up 10 different threads very quickly, dwindling your precious battery, and it's on 3G no less, right? In that situation, do you really want to make 10 different network calls and have to do authentication handoffs each time? Or would you rather just have one and get all the data back as fast as possible and have all the composition, the orchestration and composition done server side? I think that latter option is a much better option, don't you? So we're going to use GraphQL to do that. And GraphQL solves this problem because it gives you a couple things. First of all, it gives you schema. So I'm going to rename this to GraphQL. I'm going to create a new file in there called schema.graphqls. And in there, I'm going to describe a query. Now, in GraphQL, you have 3 verbs: queries for reading data, subscriptions for reading ongoing data like sensor data or chats or stock tickers or whatever, and mutations for updates to state on the server side. And that's it. When I say mutations, I mean, when I say update, I mean delete, change, add, whatever. Anything that does, leaves a side effect, that's a mutation. So there's no arguing about, oh, should I use put or post? Do I use a location header? Do I use status code HTTP 200 or 201 or 202? I don't know. You don't have to worry about that anymore. It just goes away. Now, I'm gonna create an endpoint. I'm gonna describe a type that has a query. Types have fields, right? So I'm gonna describe a type called customer that maps more or less to our Java code, but this is not a strict requirement. It doesn't have to map. In fact, that's one of the benefits, is that there's a bit of indirection here. So I'm gonna describe a field that returns an array, that's these bracket notation, of customers here, right? And I could create another one, customers by name customer, right? And this is a field that has a string parameter, right? So you can do either one of these. And I'm going to now implement this query, creating a controller here. So I'll say add controller, and I'm going to use the Spring for GraphQL project. So customer GraphQL controller, and I'll say query mapping publisher of customers by name, argument, that's the GraphQL equivalent, right? Name, return, and I'll create another endpoint here, query mapping mono of customer. Which one do I have here? Customers by name. It should just be one customer, but here multiple customers. So I want one customer here, and we'll call this customer, and we'll say customers. This should be multiple. Okay, there we are. In order to implement this, of course, we're going to inject our newly minted customer client, our reactive non-blocking client. Although you can use blocking types, I think you'll find that using non-blocking reactive types is just a better deal all around. So we'll leave that there. This.cc.by name, passing in the name, like so. Okay, so there's our, let me see, what does this give me? By name. Oh, this should be just a mono, let's just suppose, okay? Actually, no, you know what? Maybe I should make that a flex. So this will be a publisher And then back here in my schema, we'll say customers by name, and there we go. Good. I think that makes more sense because there could be more than one with the same name. Good. So there's my rewritten GraphQL controller. I'm using query mapping. There are equivalent verbs for mutation mapping and subscription mapping. Ultimately, they are just specializations of schema mapping, in which case you can specify the type is query and the field is called customers. But since I was using this syntax shortcut, I can use query mapping and it derives the name of the field from the method and so on. So it's just very abbreviated, very consistent. Now, in order to work with GraphQL, I want to have a GraphQL console. So I'll say graphical console enabled equals true, and I'll go ahead and restart this instance right here. Okay. Localhost graphical, 9999. There we are. So now I can actually make a query. I can look at this. I get auto completion. I get type safety. I can say find a result by name is Josh. So I can actually say I want ID and name. I get the results back. I can look for all the customers. I can specify what data I want or not want. So I want the name and the ID. Thank you. But what if I just want the ID? The client only gets as much or as little data as it needs. So in that common use case of, hey, I'm going to build a search engine. Okay, well, the first page shows all the search results. And then when you click on a link, it shows the details. Well, now I can use the same endpoint to drive the abbreviated summary view and the in-depth details view, right? You don't have to like create a new endpoint that returns a larger payload now. The GraphQL engine gives you that ability. And of course, if I wanted to, let's say, integrate a fictitious sort of collaborating object, let's say I also had a profile object or a profile microservice, right? Or something like that, right? Let's suppose I had one of those. I want my customer data to also have a profile associated with it. So I can go here and create a type profile, ID, okay? And now I can actually integrate the profile. I can say, okay, this type also has a profile. In order to make that work, I can implement a schema mapping. So I can say schema mapping, type name is equal to customer, right? Mono of profile, and I need a pointer to the root customer, so I can get that. That's the root of the aggregate after all. So new, I'll just say mono.just new profile customer.id. So I'm going to use it. I'm going to give it the same ID so that you can see that they match. So now I'm going to redeploy that. Okay. And we go back here, refresh the browser. I get the, now I can say I want the profile data as well. It has a ID. I can get that as well. Whoops, what is the issue with that? Profile ID. Did I, oh, I gave it an ID. I gave it a name instead of an ID. Let me try that again. Okay, refresh. There you go. There's the ID, 1122. So I'm able to introduce new parts of the object graph very cleanly without having to change the downstream microservices. I can, and obviously I'm just doing this in memory here. I'm just doing this in my local code. But imagine instead of doing this, you're making a network call to a profile service. So given the customer ID, make a call to the network service. You can even do batch mapping. So you can say, load all the profiles for all these different customers. That way you just make one call instead of n+1 as we're doing right now. There's all sorts of possibilities. And of course, my friends, all of this turns very nicely into a GraalVM native image as well. So I'll let that compile in the background, and I'm happy to start answering questions if we have them. But I also want to thank you so much for your time. I hope you got something out of it. Please let me know in the chat if you learned something new. And of course, please don't hesitate to find me on the internet if you have more questions as well. Thank you.
Thank you so much, Josh. We have a lot of questions, a lot of amazing feedback. So let me start with the amazing feedbacks first. So a lot of folks commented that we thought Chat GPT was faster until we saw Josh live coding.
Okay, thank you.
We always knew that, but it's just now that it's out. Okay,
secret's out, huh?
Yes. So let me start. So there were a couple of questions regarding the initial questions that I asked you about the changing baselines to Java 17 and Jakarta EE 9. So one of the question was, why does Spring Initializer has an option of choosing anything below Java 17 if we are talking about changing the baseline to 17 for
I don't know.
Spring?
It feels like I'm oversight on our part. Honestly, it's hopefully we're working on that. I don't know.
Okay. So there was another question about. So Lewis mentioned about if you have anything to talk about Spring Boot Web Flux and reactive programming. I know it's not possible to cover all the topics in one single presentation. So if you already have some
Right.
pointers on this topic.
Look for the most recent version of a talk I've done called Reactive Spring. It's on YouTube by lots of different conferences, and maybe I even did one for JetBrains. I'm not even sure, but it's out there. Reactive Spring. And if you look at my Spring Tips series, just Google Josh Long Spring Tips. You'll find my YouTube series, and there's a bunch of reactive stuff in there as well over the years, for the last 5 years.
Okay, so there's another question. So now a lot of questions are coming in now. So I'm showing this on the screen. Why did you import? So this is by, I'm sorry, I can't pronounce the name. Why did you import Gateway in the GraphQL project?
Just because I wanted to show 3 different ways to connect a client to the service. So I did it all in one Java project. I did Gateway, GraphQL, and the declarative, reactive, non-blocking interface-based clients. But you can use them all independent, of course.
Okay, so there's a related question. How can I call GraphQL query without this GraphQL UI tool?
Yeah, there's countless clients for JavaScript, for your browser, for Swift, for Java, I mean, we even have a GraphQL client that you can use, a reactive, we have a client you can use. And by the way, GraphQL is using HTTP, but it's only incidental. This is not REST. This is not meant to be the natural best use of HTTP or anything like that. It's just a transport in the same way that, XMLRPC kind of incidentally treats HTTP as a transport. So you can use GraphQL over WebSockets, over RSocket, right? RSocket is a very efficient way to conduct your data. We have clients that not only understand GraphQL, but they understand it over like 3 different transports as well. So if you want to do RSocket and GraphQL, which you should, it's amazing, right? You can.
I want to take another question by Amar. He wants to know whether the Spring Boot 3 can beat Quarkus in terms of memory usage and starting time.
I don't know. No idea. But it's fast enough that at this point, for most people, it shouldn't matter, right? Like, I have no idea. But think about, it's never been about like startup time. That's a fool's errand, right? Startup time is not important for 99% of the use cases. If you want fast startup time, by the way, in Spring Boot, just use, have you heard of CRaC? CRaC, right? Checkpoint, restore, and checkpoint something and restore and something, right? That is phenomenal. I can take a JVM application, JVM, not like GraalVM, JVM, and I can start it up in 2 milliseconds. Just two. Like there's nothing faster than that. So why bother? That's not the argument I'm having here, right? The argument is what's the most efficient memory footprint, and the idea is if I can get you 1/10 of your footprint and you don't have to refactor anything, you're good, right? Just do that. Yeah,
absolutely, and that's a feature. Yeah, that's a feature in the JVM, and there's a lot of talks on this topic by Simon and a lot of other folks from Azul, I think.
Oh yeah, and they were even on the podcast. Gil Tenney was on the podcast as well years ago. So talking about CRaC, it's an amazing piece of technology. Mm-hmm. It works only on Linux, but that's where you're probably deploying anyway, right? So. Yeah.
I want to give a special shout out to Simon. He answered a lot of questions by a lot of other folks on the YouTube chat. And
thank you.
So I think we are done. There was a couple of comments. No, I think we're running out of questions. I'm sorry, we're not running out of questions, we're running out of time. So at the end, I would just like to bring up some great talk, some comments, which is compliments. Thank you, Josh.
Right.
This is another one amazing session and nice things. And
thank you.
So that's
I see those
another
questions.
one.
I see the comments and the questions. I'm so appreciative. Can I just address a few things here?
Absolutely. They just came in right now. So, yeah, sure.
Okay.
Yeah.
It's not possible to do cross compilation for different images on the same operating system, but there is a GitHub action, and you can do matrix builds in most CI environments. So there's a GitHub action for GraalVM. So if you want to do you can say, when I do a git commit and git push, it'll automatically spin up a build on Mac, a build on Linux, and a build on Windows, and you can use that. And I even have a blog on how to do cross compiles with that. I think I even have a video, right? In the GraalVM video, I think I probably even talk about that in one of those videos. Why did I use JDBC template? Just because it's simple enough, and I don't want to bring in a whole extra stack. You can totally use Spring Data JDBC. It works just fine. Do you need to use the build pack to use? Why use build packs? Because you don't want to reinvent the wheel, right? If you want to use Jib, I suppose that's good enough too. But build packs work great for lots of languages, not just JVM. But use Jib if you're happy with that. It's just build packs is supported. It's fast. It's very, very robust. It's built by people who have deployed applications at scale for years. If you want to learn Spring, by the way, spring.io/guides. Or if you want like a course, today, my friends, there's a free resource called spring.academy. Go check that out. We just announced that like a few weeks ago. Just go check it out. There's a certain point where you can actually pay and get closer to certification, but there's a lot you can do there for free. And I would just check that out right now. Can someone CRaC, CRAC, not CRACK? Yeah, CRaC. Yeah. Yes. Is it possible to live Spring T-shirt? I wish I knew. Okay. I love these shirts. I had to, they used to have these shirts on stored at spring.io. Yeah, great. I'm glad you like to talk about GraphQL. I'm not using M2, sadly. I wish I had one. I am using an M1, which are phenomenal. But yeah, I want the M2 so badly. How to learn Spring? Yeah, check that out. Is this going to be available online? The recording?
Yes, it will be hosted on IntelliJ Ideas YouTube channel. So I mentioned that in the beginning. I know folks keep asking that. So yes, it will be available right after we are done with the session.
Awesome. Oh, Mala, thank you. I hope I get to see you this year. It's a weird year for travel budget, but I sure hope that we are in the same part of the planet at some point soon. We can maybe do another podcast episode.
So now that you started answering the questions, there are a lot coming in. Do you want to answer, or we?
Sure. I have no other priorities. I just don't. If we have to kick me off, then I understand. But I'm happy to answer questions. Best way to start using Spring Boot, like I said, Spring.io guides, start.spring.io, Spring.academy, pet store product, Cheese the Academy. Josh, just a minute. What? I don't quite get it. Oh, Bob Cheese is the name, I guess. How about cross-compiling different CPU? Yeah, you can do AMD. They just announced RISC. Or GraalVM, there's a blog a few months ago announcing support for RISC-V, 5, which is amazing. And by the way, think about what that is. At the very end of that blog, interesting though that was, they buried the lead, kind of. The most interesting thing they said was the effort to port GraalVM compilation to RISC-V could potentially, maybe, hypothetically, help in the effort to compile to WebAssembly. Wouldn't that be amazing? So by doing the work to make your Spring app work on GraalVM today, that could be a pathway to WebAssembly in the not tomorrow, not next month, but maybe in the future, right? And that's imagine. How is it working with Swagger? Yeah, there's a few, Spring Fox, and there's a few others. I think Dr. Sire, if you send me a message on Twitter, Dr. Sire even has an example where he makes the Swagger stuff work with GraalVM, I think, right? There's that as well. So you can find me there. At Starbucks Man. Any other questions that I'm missing about? Would I feel secure pushing native code to production? Yes, I would. Yeah, but bear in mind, GraalVM native images don't support Java agents. So if you're doing observability with a Java agent, that won't work. That's why you should take advantage of Micrometer. That will work, right? In a native context.
So I think you have answered all the questions, the comments, which is enjoyed it. Thank you. And Yuan mentioned that he'll need to watch the video at half the speed.
Well, I'm glad. I'm sorry I had to go so fast, but we just, and then we still didn't get to cover everything.
Yes. So thank you once again, Josh. It was lovely to have you present with us. It was lovely to learn so many new features for Spring Boot 3 and Spring 6. And yes, we have questions coming in, but we can't take it now. So
quería decir que, Matías, la próxima vez voy a tratarlo un poco más despacio, okay? Sorry. Disculpe.
Oh, wow.
Too fast.
So that
I spoke
right?
too fast, he said. Yeah, but he said más despacio. Yeah, more slow. Yeah.
Okay.
Maybe next time. Awesome.
That's great. So we have a lot of fans here. So we have the speed is good. I'm a fan of Josh, and thanks and
Oh.
thanks. Okay.
Oh. Which technique best? Web client? I would use the web client and declarative interface clients like you just saw. I should do a talk in Spanish. Yeah, well, you know.
Oh,
I
yes,
stream on
that
Twitch, but
was
follow
great.
me on Twitter, on YouTube. I mean, YouTube. Follow me there. What do you
Oh,
find,
yes,
Mal? Is your YouTube or Twitch better attended?
We recently started with Twitch, so we have been on YouTube for quite a long time. So YouTube has
Okay.
better reach and audience for us, but I think that will take some time to get the traction and get as much people as
For
we
sure.
have at. And everyone is watching Josh streams live on his channel almost every day. So if you
All the
want
time.
to know about all the other topics that he talks about, do watch his channel. Thank you once again, Josh. It was a pleasure to have you. And everyone who's watching, don't miss our next IntelliJ ID live stream, which we have planned for 30th of March, where Matt Ribel will be talking about the OAuth ecosystem. So we'll see you all again.
I'll be there.
Thanks.
I love him. He's amazing.
Oh, yes, he is. Thank you so much once again. And until next time, bye.
Bye, everybody.